Hello friends and greetings for the day. Welcome back to another tutorial on ISTQB Test Automation Engineer certification. We are in chapter 8 talking about continuous improvement, and as a part of this tutorial, we are continuing ahead with the next segment, that is 8.1.2, analyze the technical aspects of deployed test automation solution and provide recommendations for the improvement. And right here, we'll be certainly talking about things which are the other candidates of the task, which can be seen as a candidate for improvement. But the question is, how would you determine that there is a need for the improvement in this particular tutorial? Well, to begin with, of course, we know that any particular product has a life cycle, and indeed, once it is released, we have continuously enhancements to an existing piece of product. Similarly, when a task is released and given to the project to be used, of course, it has continuous maintenance, and the team keeps looking forward to see what can be done better in terms of enhancements, upgrades, updates, etc. But at the same time, there are many other things which we can look forward to instead of just talking about update and upgrade. And there are several technical aspects which we should be worried about, and collecting those information which can help us to recommend that there is a need for the improvement or continuous update. So let's exactly talk about it. The very first segment is talking about that small introduction right here. That is, in addition to ongoing maintenance tasks that are necessary to keep the task synchronized with the SUT, there are indeed many opportunities to improve the task as well. These improvements may be made to achieve a range of benefit, including greater efficiency or better ease of use, additional capabilities, and certainly improved support for testing. The decision as to how this task is improved is influenced completely by what features add the most value to the project. However, to a certain extent, this segment would sound like we are talking about maintenance itself, because indeed in maintenance also, we do talk about things to be updated, improvising the usability, and probably talking about those features which can do better from the expected or maybe from the current at this point of time as a solution. So we will be looking forward way beyond that, how exactly we find out those reasons, or how exactly we determine that what could be changed. Because it's not a planned change, it's not a change request from the business. It's more about discovering the areas which needs improvement. So that discovery part plays a vital role, and that is where we are talking about this. So let's continue further, as this particular segment will talk about the deep dive of each of these components which we just listed above. So let's get into that. The very first segment we are talking about, scripting. Scripting is a very common candidate, of course, to look forward to understand that it can be updated from time to time. So let's talk about it. The scripting techniques vary from linear scripting to the data-driven approach, and on the more sophisticated, like keyword-driven testing approach as well. And it may be appropriate to upgrade the current task scripting technique for all new automated tests. The technique may be retrofitted to all the existing automated tests, or at least those that involve the greatest amount of maintenance effort. So there are 2 points discussed here, that for example, you created a task solution today, but just because you are not so proficient with your scripting skills, you might have done something which is very layman level, for example, using linear methods. But down the line, as you get more experience and more results which are more sustainable, you may look forward to talk about keyword driven to be implemented or data driven being implemented. At the same time, if you further see, we may talk about those areas which might be taking more time for the maintenance or more cost involved. And that is where we would find better ways to structurize it, or probably go with the modular scripting methods, which could certainly reduce your cost of maintenance, and talk about improving them as well. So these are some of the key areas which we can always look forward to improve from time to time, and certainly would help us to do the needful. Also to add here, of course, another area of task improvement for the test script may focus on their implementation. For example, assess the test script, test case or test steps overlap to consolidate automated tests. The test cases containing similar action sequences should not implement these test steps multiple times. These test steps should be made into function and add to a library so that they can be reused. Also, these library functions can then be used to different test cases, and this increases the maintainability of the testware. When test steps are not identical but similar, parameterizations may be necessary. right? So indeed, we are talking about those things that if you see a particular step has been repeated multiple times, we can always put them into a common library, and we can relate this back from our previous understanding of library scripting method, and this could save a lot of our time because creating it as a library function, we can use and call it whenever we want. At the same time, we should not misunderstand that these are only applicable to the steps which are repeated again and again. If your tests are unique or your steps are unique, then this particular method is not applicable, right? The other option here of we have is establish a failure recovery process for the TAS and SUT. When a failure occurs during the execution of test suite, the TAS should be able to recover from this condition to continue with the next possible test. When a failure occurs in the SUT, the TAS needs to perform necessary recovery action on the SUT, which is more of like reboot of the SUT where feasible and practical. Recovery scenarios could be of great help. Initially, we might deal this with very manually. For example, on failures, we can sit down and analyze where exactly the failure happens. But later, we can improve by adding recovery scenarios. The recovery scenario simply means exception handling. As we understand, there could be common mistakes which we may do with respect to data or application availability, like synchronization time, delays, etc. We can start adding more value to the script so that in case such failures takes place, then we can overcome these situations and continue with the executions, or at least pursue the further iterations of a test without any kind of road stopper. Now, further to add here, of course, we are talking about the next important segment, that is the scripting itself, but certainly more options here. That is evaluate weight mechanism to ensure the best type is being used. There are three common weight mechanisms: hard-coded weights, dynamic weights, and certainly even better way is to talk about event mechanisms. So here we are looking at multiple things. Hard-coded weights, of course, which can be a root cause for many test automation defects, given the unpredictability of the software response times, and dynamic weighting by polling, which means is much more flexible and efficient. Here we can further stage it as the task waits only the needed amount of time and no time is wasted. And second is, of course, when the process takes longer than expected, the polling will wait until the condition is true. Remember to include a timeout mechanism, otherwise the test may wait forever if there is a defect. Now, indeed, this is one of the very key aspects of the improvement in the scripting, where we don't want to delay our scripts and take longer than usual for the executions. So we make use of wait statements to perform some of the activity, because we do understand some applications have those objects which are indeed taking longer than the usual. And as it takes longer than the usual, it matters to me to define the timelines accordingly. Sometimes we can use hard-coded, in which the object is visible, but still it consumes the required time which you have given before it moves to the next line. Whereas one is the dynamic wait, where it goes based on the property or visibility factors, like as and when the object is visible, we should move on to the next step. And this is how we can look forward to reduce our effort in terms of performing these activities. So that certainly helps us to reduce a lot of time in terms of execution and making the betterment of the scripts. Whereas the third option is also right here. The third option says that an even better way is to subscribe to the event mechanism of the SUT. This is much more reliable than the other two options, but the test scripting language needs to support event scripting subscription, and SUT needs to offer these events to the TAS. A timeout mechanism is also required, or the test may again wait forever if there is a defect. So point being made is, of course, this is another option which could be event triggered. For example, when this happens, then do the next execution. So a simple way, hard-coded is where you certainly give a fixed time interval to do wait for the script to pause. Dynamic is property specific and object attribute specific. And the third one is event trigger. Like for example, when an order is placed and order number is generated, move to the next step. Now, order number generated could also be using relative properties to identify that this was visible on the screen, but can be related to an event rather, more than calling it out as an object. That means when a PNR is generated, we can move to the next steps. But at the same time, we want to remind you that if the timeout is not being used, then sometime if there is a defect on the screen, it would continuously keep running forever. But however, this is not so practical. Today, any automation tool gives you that feature that it will not run the test forever. There will be a global timeout always there, which would overcome or override the timeouts and wait statements if that surpasses. So that is where it may not run practically forever, but the point is, if your conditions are so defined, then it might also go for it. Let's further add to the next topic, and the next topic we have is, of course, to talk about the test execution. Indeed, test execution is one of the great candidates to improve. And here we are talking about when an automated regression test suite is not finished because the test execution takes too long. It may be necessary to test concurrently on different test environment if this is possible. When expensive systems are used for testing, it can be constrained that all testing must be done on a single target environment or system. It may be necessary to split the regression test into multiple parts, each executing in a definite period of time. So indeed, we understand regression testing is something which is unpredictable over a period of time. You may have large test suites. In order to perform them, you generally see if the regression test suite is taking longer than usual or is getting over and over in size, then we look forward to find alternatives to improve this component. How? Of course, you can break your systems into multiple instances of it. Like you can have multiple instances of SIT and parallelly perform them. In case there's not an option for you, for example, your target environment could be very expensive, then breaking the regression test suite and performing them at different interval of time could be another solution. However, it would be very tricky to identify which to be run first and which to be done executed later, and at the same time can be also seen as an opportunity that you can run it overnight if it is taking longer, right? So there are multiple ways by which we can handle. You can distribute it, you can do it over the weekends, or even late night executions. By the time you come next day morning, your execution would be complete. And this is how we can reduce our effort on performing regression test suites or performing them in parallel at the same time. The very next point here is talking about the further analysis of the test automation coverage may reveal duplications. Removing duplications can reduce test execution time and can yield further efficiencies. In the case of CI/CD, a good practice is to run batch jobs in parallel to optimize the test execution time. Also, it is a good practice to schedule automated batch jobs to run the different pipelines at a given time. For example, every morning to reduce the manual interaction and speed up the development process. Indeed, that's a very common step to perform. However, this is not something which should be told to you here. We all understand that regression testing is something which is may have duplications. So checking for duplications from time to time or kind of merging multiple tests to a single test could be also an opportunity for improvement. At the same time, we do have a dedicated principle on this, that is pesticide paradox, which helps you to optimize your regression test suite from time to time. If you think there are tests which are retired and no longer required, removing them could also be a betterment or improvement action. Let's move on to the next thing here. The next thing we have is to talk about verification. Of course, before creating new verification function, adopt a set of standard verification methods for use by all automated tests. This will avoid the re-implementation of verification action across multiple tests. When verification methods are not identical but similar, the use of parameterization will aid in allowing a function to be used across multiple types of objects. Indeed, the next candidate we're talking about is the verification step, for example, assertions. And as we talk about assertions, they can be same at multiple points. For example, verifying a text visible on the screen, which might be a common text in all the screen. So instead of writing this again and again, you may create it as again a function library and call it wherever you want, or maybe declare it as a variable and use this variable or call this variable whenever you need to verify a particular step. But it's not mandatory that it would be a common assertion everywhere. If in case it is different, then doing parameterization could also be another help, right? So writing the step again and again, but instead of hard coding the value, we can pass what you want to verify through an array or maybe from a variable parameter like environment parameter or maybe an Excel sheet as well. The next component here we are talking about is, of course, the test automation architecture itself. It may be necessary to change the test automation architecture to support improvements of the testability And certainly these changes may be made in the architecture of the SUT and or the architecture of the TAS. This can provide a major improvement in the test automation, but may require significant changes and investment in the SUT or TAS. For example, if the SUT is going to be changed to provide APIs for testing, then the TAS should be refactored accordingly. Adding these kind of features later in the SDLC can be quite expensive, so it is better to think about this at the start of the test automation and in the early phases of SDLC of the SUT. Indeed, this is not a primary option, however. We never say that an architecture is meant to be revised again and again. But however, over a period of time, for example, is as good as saying that when you construct a house, but after 8 years of time or 10 years of time, the trend of houses may change around you. And that is where it might be a need that you would like to demolish your house and reconstruct it with fresh look and new design. And that's where exactly the need would come. But as you understand, the cost of reconstructing the house could have reached high or could be expensive at this point of time. So we never primarily say that architecture is a candidate for revisions quite often. However, some minor changes in the architecture, for example, initially you were testing using the interface as graphical user or GUI, but later if the APIs are available, you may look forward to change your test adaptation layer from GUI to API. And yes, changing adaptation layer is a part of architecture revisions. However, you should also calculate doing this change would return you better benefits or not. If not, certainly we don't waste our time and continue to do what exactly we do. Also, to add here, the next thing we are talking about is the next factor, and of course that is the automation framework. And test automation framework certainly deals with the components of the framework itself. So often there are new version of core libraries used in the framework. Sometimes these are major updates and the latest versions cannot be immediately referenced in the TAS dependency list, as it would break the tests from many of the teams using them. Therefore, it is better to first perform a pilot and an impact analysis. After that, an adoption plan can be created. Either all the teams adopt the new version of the core library at the same time by updating the dependency in the core library layers build file, or each time individually decides when to update it in their business logic layer. Eventually, once all the team are ready to accept the new version of the core libraries, then the dependencies can be updated in the core libraries layer. So of course, the libraries which are certainly a contributor to the executions and driver as a for the SUT scripts, certainly it might change over a period of time. And as and when we identify these changes, it's a very common thing to be updated in the TAF itself. But at the same time, we should not forget that it is crucial to understand the TAF is being a shared repository or shared accessibility to many teams could be a big challenge to do an update upfront. So we must let them know, probably perform the change and do a pilot, because if in case it fails, then it will impact many projects at the same time. So doing a pilot would be good idea to see whether it is going to do the reasonable difference or not, or it may have different side effects. At the same time, if these things work out well, we may let them know that these changes are taking place and you can update accordingly. And the team would further have opportunities to decide what updates to pick up or what updates not to pick up. However, they may look forward to see these implementations as another additional activity to be done. So cost and benefit should always be calculated. And more than that, of course, the side effect is a concern which we should be pretty much looking at. The next important thing here is to set up and tear down, which is a very common activity, should also be seen as improvement action. So actions and configurations that are repeated before or after each test script or test suite should be moved into the setup and tear down methods. This way, any changes impacting the code can be updated in one place, which results in decreased maintenance effort. For example, web services call can be used to fulfill preconditions or postconditions for the UI test. Indeed, these are some of the common activities as prerequisites and postconditions, which is more of like before you begin a test and after you complete a test. Then these activities can further be simplified in many terms. Sometimes can be combined together in terms of like there are multiple prerequisites, then we may invoke it from a common source, and then we can look forward to reduce the maintenance cost of it. Of course, you cannot remove the preconditions, but you can certainly reduce the cost of maintenance and may use different variable like environment parameters to perform them accordingly. Finally, moving to the last segment of it, the next segment and the last segment we have is other set of things which we can consider. Of course, one is documentation. This covers all form of documentation from the test automation documentation, which includes example like what the automation code does and how it should be used, user documentation for the TAS, and the test report and test logs produced by TAS, which is pretty much straightforward. And we understand that there might be documentation pattern and template what you might have used long back, and that might be old enough in a way that is written. So you can look forward to reduce the cost of maintenance by improving it in a way that can be automatically done or can be generated by the system itself. That means the task solution which you're providing, or should be written in a way which requires minimum maintenance to increase your efficiency towards it. However, the next thing we have is the task features. Add task features and functions such as detailed test reporting, test log, and integrations to other systems. Only add new features that will be used. Adding unused features only increases complexity and decreases reliability and maintainability. Task features are all other features which you're using in the task. Certainly, the basic and straightforward thing is that add only those features from time to time which are really needed. It's not that just because we found it, we are doing it. If it is beneficial to the team, it is going to be used, we include them. Because if you are not using it, then certainly it is all that it is doing is increasing the complexity and certainly reducing the maintainability. And the last and final thing we have for you is, of course, to talk about the updates and upgrades of the TAF. By updating or upgrading to a new version of the TAF, indeed, the TAF basically takes you for the new functions may become available that can be used by the test cases, or failures may be corrected. The risk is that updating the TAF by either upgrading the existing test tools or introducing new ones might have an adverse impact on the existing test cases. Test the latest version of the test tool by running sample tests before rolling out the new version of the test tool. The sample test should be representative of the automated test of the different SUT, different test types, and where appropriate, different test environment. Now, these are those changes which comes externally. For example, of course, we are using different tools connected into this entire solution. So there might be that the updates and upgrades which happen from their side. Now, each update and upgrade should be tried in a sandbox first, that whether this would have any kind of side effect or kind of maintenance requirement from the team. Because again, at the end of the day, there are many projects which might be using your solution. So it is very important for us as more of like an administrator that we are going to cross-check and verify that these changes will not create a heavy impact on the team. And if in case so, we may look forward to see how exactly to deal with that before we roll it out to the entire organization. And this went a little longer for sure, but indeed these were all the topics which we should have covered together. So it talks in one single context. So that's all from this particular tutorial team. Should you have anything else, feel free to comment below. I'm always there to address your queries and answer them well. Till then, keep learning, keep exploring, keep understanding the context. Thanks for watching the video team, and happy learning.